All right, we are going to the unit called transformations. So transformations, thinking of the word, not even pertaining to math, when you transform something, you could think of the movie Transformers. They take those big monsters, whatever, and they transform into cars. So there are a couple of different types of transformations, and the first one we're going to look at is called translations. So think about that word for a moment and think about, without even pertaining to math, what a translation is. And maybe you've landed at taking a word in one language and communicating that same word to someone that speaks a different language. So for example, in English, we have the word house. And this word, we know in English, we know what it means. But some places, in other places, we can't just say house. We're going to have to communicate this same word, house, in another way. In the Philippines, in Tagalog, which is the national language of the Philippines, they say the word bahay. So in order to properly communicate the word house in the Philippines, you would want to say bahay. So you're taking the same exact word and just moving it to a new location. So you're moving it from English to Tagalog, but it still means house. So with that being said, we're going to take geometrical figures and we are going to translate them to new locations on what we call a coordinate grid. So one other thing that they may call a translation, you might hear the word slide. So when you translate a shape or a thing, you could slide it to a new location. So think about on the playground, right? We have a slide. If there were a child, right, and they were to slide down this slide, so if they were to go down this slide, that same child would end at the bottom. So there's the child didn't change, it's all the same. So with our geometrical shapes, as we translate our shapes around our coordinate grid, our graph, the shape is not going to change shape or size. So let's go ahead and look at one way that we can be asked about translations. So here's our first one. So just like in Simon Says, I guess, so they're telling us to take our shape and to move it 1 unit left and 2 units down. So we see our original shape we have here. We have this QPR shape, and they're asking us to take this shape right here, take this shape that's originally right here. We're going to call that the original shape. And they're telling us to take this entire thing, same shape. We're taking it 1 unit to the left and 2 units down. So you say, I see 1 unit left and 2 units down. So then they're just asking us to leave it there. So if you see, the shape didn't change size. Well, it changed a little bit just because of my drawing ability. But you can recognize that it has the same shape, same size. And so the thing about this is sometimes you'll need to do something a little bit different. So I have this cool little thing, I can move my shape around and it stays all together. But if you're doing this on your own paper, obviously you don't have that capability. So what you're going to want to do is take each of the vertices. So these that let me actually do them in a different color. If we were to take these vertices, so I'm going to color these vertices. Vertices are where 2 lines meet. Take these vertices, and we're going to move them individually, because that will then allow us to draw the shape in a moment. So I'm going to take this shape right here, this vertice Q, and I'm going to move it 1 unit left and 2 units down. So that is where the new Q location goes. And the thing about when we move one of the vertices, when we move the shape, it takes on a new name. Just like English, it's called house, but in the Philippines, it's called bahay. So when we move our Q vertice to a new location, it gets a new name. And that new name is called prime. So the prime is indicated by this line that I'm drawing right now. And that tells us that it's in a new location. So let's go ahead and do that with our other vertices. So we have R. So we have, let me go ahead and, so we have R right here. So what we're going to do with this is take our R and we're going to translate it in the same way they just told us. So we're going to go 1 unit to the left and 2 units down. So because our R is now in a new location, it needs a new name. So that new name is going to be prime. So it's not in the original, it's not the English, now we're moving it to the Philippines, right? So we need to do it with all of our with all of our vertices, all of our points of our graph. So right now, it's just P. So I just have a P because I haven't moved it yet. But in order to, once I move it, so I'm going to go ahead. Once I move it, I'm going to move 1 unit to the left and 2 units down. So now it's in a new location, so it takes on a new name, and we give it that prime. So just to, we're going to go ahead and connect our dots just to see. We're going to see our new our new located shape. So just to check, let's take our one that we originally did. So I'm going to take this, I'm going to make sure it fits over our shape. And again, my lines aren't straight, but you get the extent that we have moved our entire shape to a new location. So that is one way that you can be asked to translate a shape. Okay, let's look at another way. So you see there's some practices that you can now do according to this. So now let's move down here. So I have not said anything about this right here. It says to write a rule to describe each transformation. So what we see here, what we see in this graph right here that I'm circling with my red dot, we see 2 shapes. We see one that has R, S, and Q. And then we see another shape with R prime, S prime, and Q prime. So we know from that last example that this shape right here is our original. So this could be our English or whatever. And then this shape right here, this is our translated. So we see that because it got a new name with these primes. So all of these primes that I placed here, or that you saw before I covered them up. So what they're asking is, how did this original shape, how did this that I'm highlighting in yellow, how did that original shape get to the translated shape? So there is a mathematical way of describing this, and I'm going to teach you about it right now. So how rules are written, just like we have rules in life, rules in the classroom, we are going to first start with a coordinate pair that looks like this, x, y. So this indicates your starting or original. And just like arrows direct things to places, you see arrows on the roads, you see arrows leading you to different buildings. This arrow that I'm drawing right now is telling us we don't want to stay at this original. We want you to translate it, move it to a new location. So we're going to talk about how we're going to write that specifically. So first we need to address some of the parts of this graph here. So we have an X and a Y axis. So the X is associated with left and right movement, and Y is associated with up and down movement. Hopefully that makes sense, because we have, so we have our Y right here, we have our Y, and then we have our X, which is horizontal, which moves left and right. So hopefully that makes a little bit of sense. So we have our X, which moves left and right, and our Y that moves up and down. So then we also have positive and negative movements. So a positive movement is associated with right and up, and our negative movement is associated with left and down. So we're going to have to pair these up properly to get from our OG shape to our original shape to our translated shape. So I'm going to go ahead and erase what I have on the graph to show you how it is. Okay, so we have our, let me do it in another color so you can see it. Let's go with pink. So we have our R right here. So we have our R vertice. So we want to figure out how we got from this R right here to this R. But unfortunately, we can't just drag things diagonal. They have to only move up, right, left, and down, horizontal and vertical movements. So since our x-axis comes first, our x movements come first, we're going to see how far we need to take this R on the x-axis to get to R prime. So we're trying to figure that out. So we're gonna take our OG R, and we need to move it 1. Okay, we're not quite there yet. 2. Okay, that takes us right above our R prime. So we moved our R, we moved our X, we moved our X 2 times to the left. So I see in my description here that I'm going over with my red. So we see we moved it left, so that means it's going to be a subtraction, okay? And we moved it left, so we see an X. So we're going to have to take our X, and we're going to have to subtract 2, because we moved it 2 times to the left. All right, so then our comma comes, because that's how coordinate pairs are located. And let's go back to our R to see how to get it to R prime. So now we're going to have to move it. We're going to have to see how many it takes. So let's go 1, 2, 3, 4, 5. Okay, so that took us all the way to R prime. So now our original R is in our R prime location, but how did it get there? We had to move it 5 down. So our Y is associated, so let me get my little pointer. So our Y is with up and down. We moved down, okay? So that means our Y is going to come in. But then we moved it down, which is right here, which is associated with a negative. So we're going to take that and subtract, and we moved it 5 times. And that right there, this right here, is how rules are written. So you take your original that I'm highlighting right here. It's just represented by an XY plane coordinate pair. And then we take our arrow, which represents our change, and then we do both of our X and Y, and we label it with our little key right here. This is our key. So we're going to have to do that with each of our points here. So let me get my... So now that this R is in the R prime location. Remember, it can't just stay R. We're going to have to add that prime mark, which says it's no longer in the original location. So we have to move the whole shape. So let's take this S. So we're going to take our S, and according now to our rule that we wrote, we know that we have to move 2 on the x-axis, and we're moving them to left because it's a negative. We're going to take this S and we're going to move it to left, but we're not in the S prime location, so now we're going to look back at our rule. We're going to move 5 down on the y-axis. So let's take this S and move it 5 down. 1, 2, 3, 4, 5. Okay, we made it to our S prime location, so now it's no longer, it's now an S prime. It's a new language. Okay, now let's take our Q. So we got our Q here, and let's do according to our rule. So again, on our x-axis, we're moving 2 to the left because negative is left. So let's take our Q and move it 2 to the left. 1, 2, and we're not quite there yet. So we're going to look back at our rule, and we're going to take our Y, which is up and down, and we know that we're going to move down because of a negative, and we're going to move it 5 times. So take our Q and move it 1, 2, 3, 4, 5. And look at that. We made it right to the vertice, and there becomes our prime. All right. So now we have our new translated shape in our new location, and here is the rule. So this is called your rule. Okay? All right, and then the last thing that they can ask you to do is, now this is your rule. So now we're going to have to take this rule and kind of break it down like by the key that we wrote up here. So the key that we wrote up at the top just before this. So we know that X, this is for, maybe zoom in a little bit. So the X here, this is with left or right. And subtraction is left. Okay? And then our Y is, again, with the up and down movements. But this subtraction tells us we're going to move down. So we're going to move down left 3 and down 2. And so we're going to take so that's right here is our original. And we're going to move each of our vertices left 3 and down 2. So let's go ahead and take them one at a time. So let's start with S. We'll start with this S. So they're telling us to move it, to translate this vertice left 3, 1, 2, 3, and down 2, 1, 2. So it's no longer in the original spot, so what do we have to do? We have to add the prime because it's in a new location. And then we're going to take our T, because we have to move the entire shape. We're going to take this T, and we're going to move it left 3, 1, 2, 3, and down 2, 1, 2. So again, new location, so now this becomes T prime. And our last here is R. So let's go ahead, according to our rule, we're going to take it left 3, 1, 2, 3, and down 2, 1, 2. Okay, so it's a new location, so now we have to remember to add our prime. So I'm going to go ahead and connect my dots. Connect my dots, and then we can check. So we have translated. I'm going to go ahead and just so I'm going to take my whole shape, And you see how it perfectly fits right over our original shape. So we took our original whole shape and we translated the whole thing left, 1, 2, 3, and down 2, 1, 2. And you see how that moved so nicely together, and that is it.